Find the disk of convergence of the complex power series summation k1 to infinity e to the ik over k squared times z minus 2I to the k. So first notice we're starting with k equals 1 to avoid division by 0 because of k squared. Next, this is a power series centered at 2I, because a power series has the form z minus z0 to the k. The minus is built into the formula. We do have the minus here. So our center at z0, so z0, the center is 2I. So the disk of convergence is going to be centered at 2I and then have some radius rho. So we have to figure out rho. Rho is 1 over L, where L is the limit, or lim sup as the case may be, of either, that comes from either the ratio test or the root test, the kth root of the modulus of ck, or if it exists, the lim sup of the ratio ck plus 1 over ck modulus. So either one of those will work. Let's use the root test. Ck is e to the ik over k squared. The modulus of ck is 1 over k squared, because the modulus of e to the ik is 1. That is a point on the unit circle. E to the ik is cosine k plus I sine k, and that is on the unit circle at the angle k radians. So then we need the kth root of 1 over k squared, and we want to take the limit of that. This limit exists, so we don't need the lim sup. The kth root of 1 is 1, and we need the kth root of k squared. That's the same as, and we still need the right limit here, and the kth root of k squared is k to the power 2 over k, which is k to the 1 over k quantity squared. And the kth root of k, or the nth root of n, goes to 1 as n over k goes to infinity. So 1 squared. So this is 1, and that's L. And so rho is 1 over L, which is 1 over 1, which is also 1. So that's our radius, is 1. So the disk is d2I1. So this series will converge in the complex plane in a disk of radius 1 around the number 2I. So it will include 3I. On the boundary will be 3I and 1I. And we have what's called an open disk. The boundary points are not included. The power series may converge at some points on the boundary and diverge at others. That's a case-by-case situation. More details on this limit, if you want the limit as k goes to infinity of k to the power 1 over k, we have to use L'Hopital's rule with e to the log of k to the 1 over k. The 1 over k comes to the front of the logarithm, and you get the limit as k goes to infinity of e to the power 1 over k log k, and this limit is 0 because k grows faster than log k. Log k over k goes to 0 as k goes to infinity. So this is e to the 0, which is 1. Okay, so there's our answer. The disk of convergence of the complex power series, center at 2I, radius 1. So the disk d 2i comma 1.